Have you ever wondered how data gets routed and selected in digital systems? Well, it's a fascinating process that lies at the heart of digital logic and design. Efficient routing and selection of data is crucial in digital systems. It ensures that the right data reaches the right place at the right time, maximizing the use of resources and enhancing system performance. Imagine a busy intersection in a city. Without traffic signals or a traffic cop, chaos would ensue, wouldn't it? Similarly, in digital systems, certain components serve as traffic cops, directing the flow of data and ensuring that everything runs smoothly. They dictate which data path should be used and when, thus preventing data traffic jams and bottlenecks. In the world of digital systems, two such components play a crucial role. They're like the unsung heroes of data routing and selection, working behind the scenes to ensure efficiency and precision. Two such components that aid in data routing and selection are multiplexers and demultiplexers. First up, we have the multiplexor, often abbreviated as MUX. A multiplexer is a crucial component in digital logic, acting as a high-tech traffic director for data. It's a combinational circuit that boasts multiple input lines, one or more select lines, and a single output line. Now you might wonder, what's the use of this? Well, imagine you're at a bustling train station with multiple incoming tracks, but only one outgoing track. The station master, much like a multiplexer, needs to decide which incoming train gets to use the outgoing track at any given time. Let's consider a simple example to understand this better. Picture a 4-to-1 multiplexer. It has 4 data inputs. Let's call them D0, D1, D2, and D3. It also has 2 select lines, S1 and S0, and a single output, Y. The select lines here are like the station master's control panel. They determine which data input gets routed to the output, much like how the station master decides which train gets to use the outgoing track. When both select lines are 0, D0 gets the green light. If S1 is 0 and S0 is 1, then D1 is selected. Similarly, if S1 is 1 and S0 is 0, D2 gets the nod. And finally, when both select lines are 1, D3 is chosen. This multiplexer, then, is a nifty little device that can select one input line from many based on the select lines. It's like our station master, efficiently managing the flow of data to ensure that everything runs smoothly. So to sum up, a multiplexer is a combinational circuit that allows the selection of one input line to be routed to the output line based on the select lines. It's an essential component in digital systems, enabling efficient use of resources and optimizing data paths. So that's the multiplexer, an efficient traffic director for data in digital systems. Now let's flip things around and look at the demultiplexor, or demux for short. To understand demultiplexers, imagine a post office sorting center. You have a single stream of packages coming in, and these need to be routed to different destinations. That's essentially what a demultiplexer does in digital logic. So a demultiplexer is the reverse of a multiplexer. It takes a single input line and routes it to one of several output lines. The route is determined by the state of the select lines. In other words, the demultiplexer takes in one input and can send this input out to one of many possible outputs. Let's consider a simple example of a 1-to-4 demultiplexer. This kind of demultiplexer has a single input, 2 select lines, and 4 output lines. The input could be any binary data, and the select lines determine which output line the input gets sent to. Here's how it works. If the select lines are in state 00, the input data will be sent to the first output line. If the select lines are in state 01, the input data will be sent to the second output line. Similarly, the states 10 and 11 would send the input data to the third and fourth output lines respectively. So you see, the demultiplexer acts like a traffic officer, directing the flow of data from one input to multiple outputs based on the instructions given by the select lines. It's also important to note that only one output line is active at a time. This means that the input data is sent to one and only one selected output line. All the other output lines remain inactive or at 0. In the grand scheme of digital logic and design, demultiplexers play a key role in distributing data to where it's needed. They're used in a variety of applications, including data routing, memory addressing, and even in some types of decoders. And that's the demultiplexor, the multiplexer's counterpart, efficiently distributing data to multiple destinations. You might be wondering, where do we actually use these components in digital systems? Good question. Let's delve into the world of multiplexers and demultiplexers to uncover their practical applications. First off, multiplexers, or MUX for short, are incredibly useful in data routing. They can neatly package multiple input signals into one line for transmission. This is particularly handy in communication systems, where multiple data streams need to be transmitted over a single communication line. This way, we can efficiently use our resources without compromising the data's integrity. Another application is in memory chips. Here, multiplexers are used to select the specific memory cell from a multitude of options. By choosing the correct binary address, the multiplexer can pinpoint the exact cell that needs to be accessed, making the process faster and more efficient. Now let's flip the switch and talk about demultiplexers, or demux. As the reverse of a multiplexer, a demultiplexer takes a single input and routes it to multiple outputs. This function is crucial in digital systems where a single piece of data needs to be distributed to different parts of the system. For instance, in a home theater system, a demultiplexer can take the digital audio signal and distribute it to various speakers, creating a surround sound experience. Additionally, demultiplexers also play a significant role in control signal generation. In digital systems, control signals are needed to manage the operation of certain circuits. Demultiplexers can generate these signals based on the input and select lines, providing precise control over the system's operation. As you can see, multiplexers and demultiplexers serve critical functions in digital systems, ensuring data gets to where it needs to go. Whether it's routing multiple signals into one line or distributing a single signal to multiple outputs, these components are the unsung heroes of digital logic and design. They optimize resource use, enhance system flexibility, and ultimately, they keep our digital world spinning. To sum up what we've learned today, multiplexers and demultiplexers are the unsung heroes in the world of digital logic and design. They play fundamental roles in data routing and selection, which is key to the efficient operation of digital systems. Let's rewind and visit the multiplexer, or MUX. A multiplexer is a combinational circuit with multiple input lines, one or more select lines, and a single output line. It's like a busy traffic cop, directing data from many different input lines onto a single output line based on the instructions from the select lines. Remember our 4-to-1 multiplexer example. It had 4 data inputs, 2 select lines, and 1 output. The binary value of the select lines determined which data input was routed to the output. Moving on to the demultiplexer, or demux. A demultiplexer is the multiplexer's mirror image. It takes a single input line and routes it to one of several output lines. It's like a dispatcher at a delivery company, directing a single package to the correct output line based on the select lines. In our 1-to-4 demultiplexer example, we had a single input, 2 select lines, and 4 output lines. Again, the binary value of the select lines determined the direction of the data. So what's the big deal about these components? Well, multiplexers and demultiplexers play a vital role in optimizing the use of resources and enhancing the flexibility of digital circuits. They are the masterminds behind efficient data routing, signal selection, and control signal generation. They make it possible to share data paths and effectively use available resources. This efficiency is critical in our digital age, where the demand for data transmission and processing is ever growing. But it doesn't stop there. Multiplexers and demultiplexers can be combined to create more complex systems. For instance, they can be used to create data selectors, data distributors, and even memory units. These hybrid systems further enhance the versatility and efficiency of digital systems. So the next time you're delving into the world of digital logic and design, take a moment to appreciate these fundamental components. Their seemingly simple function masks their immense importance in our digital world. So the next time you think about data routing in digital systems, remember the crucial roles of the multiplexer and the demultiplexer. Their behind-the-scenes work is what helps keep our digital world running smoothly and efficiently.